Welcome to another Ask STARBASE. Today our question comes from an explorer named Mr. Science from IMS. His question, what is quantum physics? I'll try to explain it, but it won't be easy. Okay, now let's begin. Let's begin defining quantum physics. It is the physics that explains how everything works, the nature of the particles that make up matter, and the forces with which they interact with each other. Okay, quantum physics or mechanics sustains how atoms work, and so why chemistry and biology work as they do. In some level, we are in this quantum beat. Okay. It helps us invent technologies such as computers, digital cameras, LED screens, lasers, nuclear plants. If you want to explain how electrons move through a computer, that's quantum physics. How photons of light get turned to electrical current in solar panel or amplify themselves in a laser, that is quantum physics. Or even just how the sun keeps burning, that's quantum physics. It's the part of physics that describes the smallest thing of our universe. Molecules, atoms, subatomic particles, and things like that. You and everything around us is made of quantum physics. This is how the whole universe is working. In quantum physics, everything is described as waves instead of electrons. Looking like this, it should look something like this wave function. Not physically real, but an abstract mathematical wave. The difficulty or the fun starts here. There is no single quantum theory. There's quantum mechanics, the basic mathematical framework that builds it all, which was first developed in the 1920s by Niels Bohr, Werner Heisenberg, Erwin Schrödinger, and others. It characterizes simple things such as how the position or momentum of a single particle or a group of particles changes over time. But to understand how things work in the real world, quantum mechanics must be combined with other elements of physics, mainly Albert Einstein's special theory of relativity, which explains what happens when things move very fast to create what are known as quantum field theories. 3 different quantum field theories deal with 3 of the 4 fundamental forces by which matter interacts. 1. Electromagnetism, which explains how atoms hold together. 2. The strong nuclear force, which explains the stability of the nucleus at the heart of the atom. And 3. The weak nuclear force, which explains why some atoms undergo radioactive decay. Over the past 5 decades or so, these 3 theories have been brought together in a chaotic coalition known as the Standard Model of Particle Physics. It is the most accurately tested pictures of matter's basic working that has ever been conceived. Its crowning glory came in 2012 with the discovery of the Higgs boson, the particle that gives all other fundamental particles their mass, whose existence was predicted based on quantum field theories as far back as 1964. At a basic level, quantum physics predicts very strange things about how matter works that are completely at odds with how things seem to work in the real world. Quantum particles can behave like particles located in a single place, or they can act like waves, distributed all over space or in several places at once. How they appear seems to depend on how we choose to measure them. And before we measure, they seem to have no definite properties at all, leading us to a fundamental problem about the nature of basic reality. This fuzziness leads to apparent paradoxes such as Schrodinger's cat, in which, thanks to an uncertain quantum process, a cat is left dead and alive at the same time. But that's not all. Quantum particles also seem to be able to affect each other instantaneously, even when they are far away from each other. This truly tricky phenomenon is known as entanglement, or, in a phrase created by Einstein, spooky action at a distance. Such quantum powers are completely foreign to us, yet are the basis of emerging technologies such as ultra-secure quantum cryptography, which is the only known method for transmitting a secret key over distance that is secure in principle and based on the laws of physics. It enables two parties to produce a shared random secret key known only to them, which can then be used to encrypt and decrypt messages, and ultra-powerful quantum computing. This is the use of quantum phenomena such as superposition and entanglement to perform computations. Computers that perform quantum computations are known as quantum computers. But as to what it all means, no one knows. Some people think we must just accept that quantum physics explains the material world in terms we find impossible to square with our experience in the large classical world. Others think there must be some better, more intuitive theory out there that we've yet to discover. In all this, there's a fourth fundamental force of nature that so far quantum theory has been unable to explain. Gravity remains the territory of Einstein, general theory of relativity, a firmly non-quantum theory that doesn't even involve particles. Intensive efforts over decades to bring gravity under the quantum umbrella and so explain all of fundamental physics within one theory of everything have to come to nothing. Mr. Science, this is not an easy topic. I will leave here some links that you can access later on. Remember, explorers, if you have any doubts, any questions, any curiosity, don't hesitate to write us at ask@starbase-ct.com, and we will gladly answer your questions. Take care and goodbye.